Hi friends, now we are going to know about velocity of steam at the same time mass of steam discharged through nozzle today. Okay, now here I am written velocity of steam at nozzle exist. Okay, here velocity of steam at nozzle exists. V2 square is equal to, this is for standard equation. Okay, therefore we can return this V2 is equal to whole root of h1 minus h2 plus v1 square. So as the velocity of steam as the velocity of steam entering the nozzle is very small, so that v1 can be neglected. So therefore you can above equation you can write root of 2000 h1 minus h2. Okay, then it will come out of this 2000, the value it will come around 44.72 h1 minus h2. This is the meter per seconds. Units of velocity is meter per seconds. Hence, you can write here small hd is equal to h1 minus h2. Okay, so you can put it here capital H, you can put capital H, small h is small h, right? So now you can find out this hd is equal to h1 minus h2. Okay, if friction loss are taken, if frictional losses are taken into account, then V2 is equal to 44.72 root of h1 minus h2 efficiency of nozzle. Okay, or otherwise you can return this equation hd into efficiency of nozzle. Okay, this is the equation to find the velocity of steam at nozzle exist. Then we go for mass of steam. Mass of steam discharged through nozzle. Discharged through nozzle. Then here I can write down mass standard equation. (2000) n by n minus 1 into P1 V1 pressure and velocity. Okay, now here P1, sorry, this is coming from P2 divided by P1. So yesterday we see the dynamic shaft chart. now n, now P2 by P1 n plus 1 divided by n. Okay, this is the mass of steam discharged through nozzle equation. Now condition for maximum discharge through nozzle, but here we need maximum discharge through nozzle. So then I can written here condition for maximum discharge through nozzle. Okay, so how can you find out? You can see the nozzle is always designed for maximum discharge. The nozzle is always designed for maximum discharge. Then you can write down the equation m by a is equal to whole root of 2000 n by n minus 1 into P1 V1 P2 by P1 2 by n minus P2 by P1 n plus 1 divided by n. Okay, now the mass flow per unit area, the mass flow per unit area will be maximum at the throat. Where? At the throat, because the throat area is minimum. The throat area is minimum. So it is seen from the above equation. The discharge through a nozzle is a function of P2 by P1 only. The function of P2 by P1 only, as the expression index is fixed according to the steam supplied to the nozzle. Okay, so therefore you can write down here therefore m by a is maximum when మనం చెప్పుకున్నట్టుగా ఇప్పుడు above equation the discharge through nozzle is a function of P2 by P1. సో టోటల్గా మనకి థ్రోట్ అనేది మినిమంగా ఉంటుంది కాబట్టి ద మినిమం డిశ్చార్జ్ ఆఫ్ ఫంక్షన్ ఈజ్ హియర్ ప్రెషర్ P2 by P1. Then we can take this expression separately. Okay, so P2 by P1 2 by n P2 by P1 n plus 1 n. So now this is minimum. Okay, minimum value for maximum discharge. So now here value for maximum discharge, value for maximum discharge M is equal to A root of 2000 n by n minus 1 into P1 V1. Now the minimum discharge of throat, okay, we know here P2 by P1 is equal to 2 by n plus 1, that whole power n by n minus 1. Okay, now this is for throat equation. Now substitute this here, putting the value of P2 by P1 in the above equation. This is thermodynamic throat equation. So now we put in above equation, we get M maximum, that is equal to A into 2000 n by n minus 1 into P1 V1 into, now here we are going to substitute the value of P2 by P1. Now what is that? 2 by n plus 1, okay, n by n minus 1, okay, n by n minus 1, and here we can, so now 2 by n into 2 by n minus, again you can write here 2n plus 1 into n by n plus 1 into n plus 1 by n minus 1. Got it? Now here this is n minus 1, okay, n by n minus 1, n by n minus 1, this value we can return into, already n plus 1 divided by n is there, so we can put n plus 1 divided by n. Similarly here also you can return 2 by n plus 1 n by n minus 1 into 2 by n. Okay, we solve the above terms, then we can write down here M maximum is equal to root of 2000 n minus 1 into P1 V1 2 by n plus 1 2 by n minus 1, then 2 by n plus 1 n minus 1. Okay, we solve this, we can find finally this equation. Okay, and now here we are going to solve this equation. I put all constants is same, but in here 2 by n plus 1 whole power n plus 1 divided by n minus 1. Then I can take outside from this. So 2 by 2 plus 1, so n plus 1, 2 by n plus 1 whole root of 2 minus 1 minus of n plus 1 and minus 1 over minus 1. Okay, you can multiply this thing, you will get same answer. So now here again we solve this. What happened in this equation can change p1 v1 into 2 by n plus 1 n plus 1 and minus 1. Now here 2 by n plus 1 all power 1 minus n divided by n minus 1 minus 1. Okay, and again I solve this. 2000 n by n minus 1 p1 v1 into 2 by n plus 1 n plus 1 whole power by n minus 1. So now here we get here 2, we get a LCM, we take an LCM, we'll get this answer 1 minus n by n minus 1. Okay, and now here we can solve this one, take LCM for this n minus 1, we will get this answer for this 2 by n plus 1 minus 1 1. Okay, so now you solve this one, you'll get minus 1 in here. Okay, now you can write down the equation in here is here, look at this minus 1, so then I can write reverse in this formula. Okay, minus 1 means it will come reverse. Okay, that's why I put it here n plus 1 by 2, n plus 1 by 2. Now then I'll take this in bracket terms, you can take LCM for this 2. What we will get? Now in here 2 by n plus 1 n plus 1 n minus 1 is the same thing, but now in here we will get n minus 1 by 2, this term. Okay, this term we can write here n minus 1 by 2. Okay, now in this 2 it will go once, and any this thing here and here will cancel. Okay, right. Okay, no more cancels in here, so no more terms will cancel. So finally we can write m maximum is equal to A into 1000 N into P1 V1 into 2 by N plus 1 whole power N plus 1 divided by N minus 1. So where P1 is equal to initial pressure of the steam in kilopascals. You can write V1 is equal to, V1 is the specific volume. V1 is specific volume of the steam in meter cube per kg at initial pressure. Okay, so this is the procedure to solve the maximum discharge of steam at outlet. At the same time, condition for maximum discharge through nozzle and velocity of steam at nozzle exists. Okay, we are going to use these equations to find velocity of steam at nozzle and at the same time maximum discharge through nozzle. Okay, so this is the terms. Here we are going to, very well important thing is remember this formula, this equation mainly. This is main equation, and now here we are getting the equation, final equation is here. V2 is equal to 44.72 HD and nozzle efficiency. Okay, in here we will find out the nozzle efficiency also. Okay, here in this equation we can find out nozzle efficiency also in here. So now this is the term, since here you put since HD is equal to H1 minus H2. Okay, here you can substitute in this place in HD. That's I put it in here. Okay, this is the most important thing. And now here this is for mass discharge, mass steam discharge through nozzle. This is basic equation. Okay, and now we go for here to find the minimum discharge of nozzle. This is for minimum discharge of nozzle. So you can use this equation frequently to solve the problems. And finally what we will get in here, yes, this thing. This is the final equation. Okay, the maximum discharge. M is coming from mass, maximum mass discharge. Okay, so this is the equations. Okay, tomorrow we are going to solve problems. Thank you.